Typically, car manufacturers don't build car factories in dense urban cities like.
The EV industry, as we know it, is about to change forever. These were Elon Musk's bold words, spoken with the kind of confidence that has both inspired and unnerved his competitors over the years. Today, we're diving into an announcement that sent shockwaves through the EV market and innovation so groundbreaking that rivals are scrambling to catch up. So let's get right into it. The EV revolution's hidden challenge. When Elon Musk speaks, the world listens, and his recent statement is making quite a stir in the EV world. He promised to show a new engine that will destroy the EV industry as we know it. But to truly grasp the magnitude of his recent announcement, we must take a step back and understand the technical aspects that underpin his claim. Behind the flashy exteriors and futuristic marketing of electric vehicles lies a persistent challenge that has quietly haunted the EV industry for years, one that could determine the fate of sustainable transportation. Electric vehicles have come a long way since their humble beginnings, transitioning from niche curiosity to mainstream mobility in 2023. EV sales hit record highs globally, driven by supportive legislation, falling battery costs, and a shift in consumer preferences toward eco-friendly options. Leading the charge are Tesla, Rivian, Lucid Motors, and legacy automakers like Ford and General Motors, all competing to create electric cars that offer the perfect blend of range, performance, and affordability. Yet despite this growth, significant technical hurdles remain. Range anxiety, for instance, continues to plague the industry. While manufacturers tout figures of 300 miles or more on a single charge, real-world conditions often fail to meet those promises. Battery production presents its own headaches. Materials like lithium, cobalt, and nickel face supply chain issues that challenge scalability, making widespread EV adoption increasingly complex. Beyond batteries, another bottleneck emerges: the electric motor. Efficiency and power are locked in a constant tug-of-war. On the one hand, manufacturers strive to maximize power density, packing more energy into smaller, lighter systems for speedier acceleration and higher top speeds. On the other hand, these same manufacturers must balance energy usage to avoid rapidly depleting the battery and hampering the range. Achieving this balance often results in compromise, a concept Elon seems almost allergic to. Tesla, often seen as synonymous with EV innovation, has faced its share of struggles in refining this equilibrium. The company has pushed boundaries, producing vehicles like the Model S Plaid that boasts a more than jaw-dropping 1,000 horsepower and a 0 to 60 time of under 2 seconds. But even Tesla has acknowledged that further breakthroughs are needed to meet the industry's soaring demands without sacrificing efficiency or affordability. And here is where Elon's latest statement becomes critical. Whispers have long circulated about Tesla developing cutting-edge technologies to leapfrog its competitors. Hints of a revolutionary motor design, a step so radical that it would make their closest rivals' progress obsolete, have kept industry insiders lingering. Still, Elon has remained tantalizingly tight-lipped about specifics, choosing to stoke curiosity and skepticism in equal measure. To truly disrupt the status quo, Tesla will need to address a major question. Can performance and efficiency finally coexist without compromise? As whispers of Tesla's secret development grow louder, competitors like GM and Volkswagen are racing against the clock, attempting to fortify their own lineups before the next major leap renders them irrelevant. But as it turns out, Tesla's game-changing innovation didn't emerge out of nowhere. It was forged from years of studying, iterating, and solving problems that others deemed unsolvable. Stay with us, as we will soon unveil how Tesla's audacious journey continues to shake the very foundations of the auto industry and what this could mean for the cars of tomorrow. Tesla's journey to dominance in the early 2000s, when electric cars were synonymous with golf carts and uninspiring prototypes. Few would have bet on an unknown Silicon Valley startup changing the future of transportation. Yet today, Tesla stands not just as a leader, but as a symbol of innovation, resilience, and audacity in the automotive industry. Its rise from obscurity to dominance has been nothing short of extraordinary, with each milestone paving the way for a revolution and something even more game-changing on the horizon. Tesla's journey began in 2003 with a dream shared by engineers Martin Eberhard and Mark Tarpenning to prove that electric vehicles could be as practical and desirable as their gas-guzzling counterparts. While their early vision laid the foundation, the arrival of Elon Musk in 2004 as an investor and visionary leader catapulted Tesla onto a whole new trajectory. Elon poured millions of his own money from his PayPal fortune into Tesla, quickly taking the reins and guiding the company with a vision that would blend sustainable energy with cutting-edge technology. The company's first production car, the Tesla Roadster, launched in 2008, was a bold statement. Are we making a difference in the world? And for us to make a difference in the world, we have to build a lot of cars. Unlike other electric cars at the time, the Roadster wasn't an underpowered commuter. It was a sleek, high-performance sports car capable of accelerating from 0 to 60 miles per hour in under 4 seconds. This impressive debut proved that electric vehicles didn't need to compromise on style or performance, instantly positioning Tesla as a serious player in the automotive world. But Elon wasn't satisfied with niche luxury vehicles. His infamous secret master plan, published in a 2006 blog post, revealed a roadmap to bring EVs to the masses. The plan laid out 3 key steps. First, develop a high-priced car to fund development. Second, use those profits to create a moderately priced car. And finally, scale to produce affordable, mass-market vehicles, all while prioritizing sustainable energy solutions. Tesla's Model S, introduced in 2012, marked the beginning of that second step, a luxurious electric sedan with cutting-edge features like over-the-air software updates and unmatched range. The Model S redefined what EVs could be. Awards and accolades poured in, solidifying Tesla's reputation as a leader in both innovation and quality. Its all-electric powertrain, complemented by Tesla's proprietary battery technology, demonstrated superior performance while offering an industry-leading range, a key selling point that would define the brand. With the 2015 launch of the Model X SUV and the unveiling of the Model 3 in 2017, Tesla completed the puzzle. The Model 3 was a turning point, a reasonably affordable sedan designed for mainstream appeal, backed by an army of pre-orders before production even began. The Model 3 became Tesla's best-selling vehicle and the poster child of the EV revolution. Its streamlined production process and economies of scale gave Tesla the foothold it needed to transition from boutique innovator to industry powerhouse. Central to Tesla's success is Elon's relentless focus on the future. Under his leadership, Tesla transformed not only the perception of electric vehicles, but also the manufacturing process itself, from vertically integrating. Tesla's approach has been to innovate at every level. This philosophy extends beyond cars, encompassing the Powerwall home battery, solar roof tiles, and even ventures into AI with Tesla's self-driving technologies. All of these reflect Elon Musk's vision for a sustainable, interconnected ecosystem. Musk's approach has always been to think big and stay ahead of the curve. With the unveiling of Tesla's Model Y crossover and the long-awaited Cybertruck, Tesla expanded into new segments, broadening its customer base and leaving competitors scrambling. Alongside these products came a commitment to advancing the core technologies that drive EV performance. Tesla's energy-dense 4,680 battery cells, for example, represent a quantum leap in range and efficiency, cutting production costs while enhancing power output. While competitors fixated on keeping up with Tesla's achievements, Elon hinted at something more radical. Tesla doesn't just want to win the EV race. They want to create something no one else even dares to think about. The hints grew louder with the rollout of the Plaid performance line, beginning with the Model S Plaid in 2021. It wasn't just the ludicrous acceleration or staggering top speed that grabbed attention. It was Elon's deliberate teasing of a breakthrough in electric motor technology, describing the upcoming advancements as a game changer. He has ignited speculation across the industry. Now you should know what truly sets Tesla apart from its competitors, and that is the constant cycle of reinvention. While automakers like GM, Volkswagen, and BMW have made strides with their respective EV lines, their pace is constrained by legacy infrastructure and traditional timelines for product development. Tesla, with its tech-first approach, continuously reinvents the fundamental building blocks of electric mobility. Behind closed doors, Tesla's research and development division has been working on technologies Elon claims will leave rivals in the dust. Insiders have whispered about a revolutionary motor design capable of transforming the efficiency, power, and durability of EVs all at once. These stories gained further traction with Elon's enigmatic announcement in late 2023, calling it a leap comparable to the transition from gas engines to electrics. Understandably, Tesla's competitors are concerned. Despite making impressive strides, traditional automakers lack Tesla's agility to quickly adopt disruptive changes. Companies that only recently managed to replicate Tesla's 2017-level technology now face an imminent risk of falling farther behind. If Tesla pulls this off, remarked one industry analyst, it could reset the competitive landscape for the next decade. With Tesla's stock on the rise and investor optimism at an all-time high, anticipation for the official reveal continues to build. And just until recently, we were left wondering just how far ahead is Tesla and what happens to the rest of the market if Musk delivers on his promise. The race for ultimate EV performance is an electrifying spectacle, a relentless pursuit where engineering brilliance collides with insurmountable challenges. At the heart of this competition is the electric motor, a technological marvel responsible for converting energy into motion. Yet, despite its promise, it is also the source of the industry's greatest limitations. It is here in the mechanics of power and efficiency that Tesla's leadership continues to outpace rivals while pushing the boundaries of possibility. Electric motors have existed for over a century, but their adaptation to modern EVs presents challenges that are difficult to overcome. Heat management, for instance, is a persistent issue. Motors capable of producing extraordinary power generate an equally extraordinary amount of heat, which can damage key components and reduce long-term efficiency. Cooling systems, while necessary, introduce additional weight and complexity, setting off a cascade of engineering compromises. Moreover, reliance on rare earth materials like neodymium poses risks that extend beyond the engineering flaw, including price volatility and geopolitical uncertainties. These constraints ensure that every incremental improvement is a hard one. Tesla's ability to balance these competing demands showcases its engineering culture, but its dominance has only fueled competitors' determination to close the gap. Automakers like General Motors and Volkswagen have poured billions into developing electric platforms capable of rivaling Tesla. Emerging players, particularly in China, such as BYD, have adopted aggressive strategies, integrating every element of production from batteries to drivetrains. Some are succeeding. BYD's diverse portfolio and cutting-edge technology make it a key contender in global EV markets. In the high-performance segment, brands like Lucid and Rivian are gaining recognition, leveraging luxury aesthetics and bespoke technology to compete with Tesla's crown jewels. Even Xiaomi, better known for its dominance in electronics, shocked the industry by achieving record-setting performance from its latest EV prototype. Yet none of these efforts have yielded a clear disruption of Tesla's standing. The technical barriers they face highlight the uphill battle that all EV manufacturers encounter. Developing a motor that can provide both power and efficiency without compromise remains elusive. For every gain in acceleration or torque, there is often a proportional reduction in range, placing an unrelenting burden on battery technology to fill the gap. Charging speeds add another dimension to the problem. Batteries capable of handling massive loads at ultra-fast speeds have yet to be perfected, even as customers demand vehicles that charge as quickly as their cell phones. Software, now a critical factor in EV performance, introduces a different complexity. It is no longer just about energy management, but also integration with advanced driver assistance and semi-autonomous systems. Seamless interplay between hardware and software is the future, but few have achieved it at Tesla's scale. And there's also their willingness to challenge the status quo. While legacy automakers wrestle with entrenched manufacturing processes, Tesla continually rewrites the rules. It starts with vertically integrating the supply chain, a decision that allows unprecedented control over components like batteries and motors. With gigafactories spread across continents, Tesla ensures scalability while driving costs down, creating efficiencies their competitors struggle to replicate. Elon, ever the provocateur, speaks often of what comes next, teasing innovations that will make today's milestones seem obsolete. These aspirations leave competitors in a reactive posture, forever following instead of leading. Industry insiders suggest that skepticism plays a significant role in tempering the ambitions of legacy automakers. Their development timelines remain bound by conventional processes that demand incremental progress over groundbreaking leaps. Experts point out that companies rooted in combustion engine technologies have a cultural and financial inertia that hinders them from rethinking their approach to electric mobility. Consequently, even their best attempts often feel like iterations rather than revolutions, allowing Tesla to widen the gap. Yet the skepticism cuts both ways. Elon's proclamations of an imminent revolution invite both excitement and doubt. Critics argue that Tesla's promises can sometimes feel overblown, pointing to past delays and ambitious timelines that required significant extensions. Still, the record is hard to ignore. Each high-profile product release, from the Model 3 to the Plaid performance line, has redefined. The market expects electric cars to deliver exceptional performance, efficiency, and a seamless user experience. Elon Musk's cryptic hints about a revolutionary new motor design have ignited anticipation within the industry. He describes a potential leap forward comparable to the transition from internal combustion engines to electric propulsion. While this has captured imaginations, it has also caused unease among competitors who struggle to decipher whether these claims are mere marketing bluster or genuine breakthroughs. Whispers of clues about Tesla's secret weapon are beginning to emerge. Analysts suggest that Tesla may be on the verge of addressing some of the most significant barriers to EV motor performance. Elon himself alluded to a motor design capable of unprecedented power-to-weight ratios, improved thermal resistance, and efficiency that breaks conventional boundaries. Observers wonder whether Tesla's research will redefine the physics of EV performance, potentially setting an insurmountable standard for others to follow. For now, competitors can only hope to keep pace, a task that grows harder as Tesla's integration of motor and battery technologies continues to improve. The introduction of Tesla's 4680 battery cells undoubtedly hints at how the company aligns its engineering objectives across different systems. It's a holistic approach that many rivals envy, but few replicate, given the depth of investment and expertise required. And as it would turn out, while other automakers scramble to keep up, Tesla marches forward both as an industry leader and provocateur. Good luck catching us, Elon quipped in a recent interview, speaking to Tesla's edge in engineering. But beneath the bravado lies an undeniable reality. Tesla's relentless pace of innovation leaves the industry wondering if there's even a race left to win. The engineering challenge nobody could solve, the development of electric motors, represents one of the most formidable challenges in EV engineering. At a glance, these motors seem like the perfect alternative to combustion engines. Efficient, silent, and capable of incredible power delivery. However, adapting traditional motor designs for EVs has exposed a host of limitations, ranging from heat management and efficiency losses to material constraints that push the boundaries of current engineering. One of the most pressing issues is thermal management. Electric motors generate significant heat during operation, particularly under high loads as seen in high-performance EVs. Excessive heat compromises efficiency and risks damaging key components such as the windings and magnetic elements. Cooling systems are necessary to mitigate these effects, but often introduce their own challenges, such as increased weight and complexity. Another limitation comes from reliance on rare earth materials like neodymium for producing high-strength magnets, critical to motor performance. These materials are expensive and subject to geopolitical instability, raising concerns about supply chain vulnerabilities and long-term scalability. Furthermore, traditional motor designs often struggle with the trade-off between efficiency and power. Maximizing one typically compromises the other, which in turn affects the vehicle's range, battery life, and overall performance. Throughout the past decade, countless companies have grappled with these challenges, with many ultimately falling short. Electromechanica Solo EV, for instance, is a cautionary tale. Promoted as a revolutionary single-seater vehicle, it failed to meet technical and consumer expectations, resulting in widespread recalls and the eventual collapse of the brand. Such failures show that even promising concepts can falter without the engineering ingenuity to overcome key obstacles. Tesla, however, has consistently defied these odds. From its earliest days, the company adopted a unique problem-solving philosophy centered on relentless iteration, vertical integration, and bold ambition. Elon's insistence on questioning industry norms has fueled innovations that push the limits of what is considered feasible in EV technology. Instead of treating traditional motor design limitations as insurmountable, Tesla has re-engineered every aspect of the process, from raw material sourcing to manufacturing techniques, to achieve groundbreaking solutions. The tension mounts. Can Tesla once again solve the challenge that has defeated so many others? The game-changing innovation? It would seem so. I mean, just listen to the words of Elon Musk. I'll show you this new engine that will destroy the entire EV industry, and it's going to get better from now on. With a statement as audacious as this, it's no wonder that the automotive world has been abuzz with speculation. The engine in question? Tesla's revolutionary plaid-wrapped rotor technology, a breakthrough poised to change the very fabric of electric vehicle performance. At the heart of this innovation, which by the way reportedly had Elon saying, "I've made my decision, I'm going to make a revolution," lies the plaid motor, a marvel of engineering that addresses the long-standing limitations of traditional motor designs. For years, electric motors have grappled with fundamental challenges: thermal management, mechanical stresses, and efficiency losses at high speeds. Elon and Tesla's engineers have not only tackled these issues head-on, but turned them into opportunities to push electric performance beyond what was previously thought possible. This rotor rewrites the playbook on electric motor design. Traditional rotors, which spin at high speeds to generate power, are typically constructed from metals like steel or aluminum. While effective, these materials face limits as the rotor spins faster. It experiences immense centrifugal force that can cause deformation or even failure at extreme revolutions per minute, RPMs. Tesla's solution was nothing short of radical. They encased the rotor in a carbon fiber sleeve, creating a structure that offers unmatched tensile strength while remaining incredibly lightweight. This carbon fiber reinforcement changes the game fundamentally. The rotor can now spin at previously unattainable speeds, reaching up to 20,000 RPMs, far outpacing conventional motors. Higher RPMs translate to greater power output without compromising efficiency. In fact, the carbon wrapping also solves a critical problem: thermal expansion. By keeping the rotor stable even under intense heat and stress, Tesla has designed a motor that maintains its performance in ways competitors can only envy. The The results are staggering. With the carbon-wrapped rotor at its core, the Tesla Model S Plaid has become a phenomenon. It rockets from 0 to 60 miles per hour in just 1.99 seconds, an achievement that has firmly cemented its place among the fastest production cars in the world. Its top speed of 200 miles per hour further highlights the incredible performance capabilities of Tesla's cutting-edge motor. This car is a statement that EVs can surpass the capabilities of combustion engine supercars. The implications of this technology extend far beyond raw speed and acceleration. By increasing power density and efficiency, Tesla has set new benchmarks for electric motor performance. The Plaid motor's compact design opens opportunities for smaller, lighter, and more efficient vehicles that retain superior performance for customers. This means longer ranges, quicker acceleration, and an unparalleled driving experience. Tesla's competitors have taken notice. In a market crowded with automakers trying to replicate Tesla's success, this innovation has deepened the gap. Many are now left scrambling to adapt, facing an uphill battle against Tesla's head start in engineering prowess. Musk's bold claim to destroy the entire EV industry doesn't feel so far-fetched when you consider the technological leap the Plaid motor represents. It's a chasm that rivals must now cross. Elon has hinted that this technology is just the beginning. Insiders suggest that Tesla's upcoming vehicles, including the second-generation Roadster and the Cybertruck, will incorporate advanced iterations of the Plaid motor, pushing torque and speed to levels that were once thought impossible. The Roadster, for example, is projected to accelerate from 0 to 60 in just 1.1 seconds, potentially using enhanced variations of the carbon-wrap rotor to achieve this mind-boggling feat. Industry analysts predict that Tesla's carbon-wrapped rotor technology will ripple through the automotive world. It challenges traditional assumptions about what electric motors can achieve and forces competitors to innovate or risk irrelevance. Legacy automakers, constrained by traditional manufacturing methods and supply chain dependencies, face significant hurdles in catching up. But there is more. This breakthrough also unlocks new possibilities in sectors beyond passenger vehicles. The aerospace industry, heavy-duty trucks, and even renewable energy systems could all benefit from Tesla's advancements in electric motor technology. The Plaid motor represents Elon's vision for humanity. By demonstrating that EVs can not only match, but exceed the performance of internal combustion engines, Tesla is accelerating the transition to sustainable energy. After all, this is just another showcase of his relentless belief that innovation can solve humanity's biggest challenges. The days of compromise between performance and sustainability are over. And yet, as Elon himself teases, the Plaid motor might just be the prelude to something even greater. What do you think will come next? Let us know in the comments.